we are going to discuss exercise 7.2. Before starting the exercise, I'll just discuss with you a few important points which you should remember while solving this exercise. The first thing is angles opposite to equal sides of an isosceles triangle are equal. Let ABC be an isosceles triangle such that AB is equal to AC. Then this theorem says that angles opposite to equal sides, which is the angle opposite to AC, it is angle B, and angle opposite to side AB is angle C. So if AB is equal to AC, then angle B will be equal to angle C. This is what this first theorem says. Okay, and the second theorem says that the sides opposite to equal angles of a triangle are equal. That means if you are given angle Q is equal to angle R, if angle Q is equal to angle R, then the sides opposite to these equal angles means which is the side opposite to Q, that is PR, and which is the side opposite to R, that is PQ. Okay, these are the two theorems which you have to remember before solving exercise 7.2. Exercise 7.2, question number 1. In an isosceles triangle ABC, AB is equal to AC and bisectors of angle B and angle C meet at point O. You have to join A to O and show that OB is equal to OC and OA bisects angle A. As we have already discussed earlier that in a triangle where two sides are equal, then the angles opposite equal sides are equal. So here you are given AB is equal to AC, therefore angle B will be equal to angle C. And so half of angle B will be equal to half of angle C. So we are going to write this. Since AB is equal to AC, therefore angle B is equal to angle C, and therefore angle B upon 2 is equal to angle C upon 2. Now if you see in triangle OBC, two angles are equal, and we have already done the theorem that if the sides opposite equal angles are equal, so therefore which is the side opposite angle B upon 2, the side opposite angle B upon 2 is OC, and the side opposite angle C upon 2 is side OB. Therefore OC is equal to OB, which is the first part which you had to prove. Hence proved. Now we come to the second part. In the second part you have to prove that OA bisects angle A. Now here you may see you have two triangles, triangle AOB and triangle AOC. We are going to prove them congruent. So let's see. In triangle AOB and triangle AOC, in these two triangles, let's see which criteria we are going to use. In these two triangles, you have AB is equal to AC. We have just now proved OB is equal to OC and OA is common. Therefore, by SSS, the two triangles are congruent. Hence, by CPCT, angle BAO is equal to angle CAO. This is what we are going to write. So in triangle AOB and triangle AOC, AB is equal to AC, In the bracket you will write given AO is equal to AO common and OB is equal to OC. We have proved just now. So by SSS the two triangles are congruent. So I will write therefore triangle AOB is congruent to triangle AOC. Therefore angle BAO is equal to angle CAO. And what does that mean? That OA bisects angle A. Hence proved. Exercise 7.2, question number 2. In triangle ABC, AD is the perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle with AB equal to AC. Here you are given that AD is the perpendicular bisector of AC. That means it is perpendicular as well as bisector. Perpendicular means that angle ADB is equal to 90 degree, and similarly ADC is also equal to 90 degree plus BD is equal to CD because it is the bisector. So two things are there, perpendicular as well as bisector. So now let's see how we are going to prove. First of all, we'll take the triangles ABD and triangle ACD. In these two triangles, DB is equal to DC because AD is the perpendicular bisector. So we'll write given. Next we have angle ADB is equal to angle ADC. Both are equal to 90 degree, which is also given. Then last we have AD equal to AD common. Therefore, by SAS, these two triangles are congruent. So I will write triangle ABD is congruent to triangle ACD by SAS, and therefore AB is equal to AC by CPCT. Hence proved. ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB. Show that these altitudes are equal. You are given a triangle ABC in which AC is equal to AB and BE and CF are altitudes on AC and AB respectively, means that BE is perpendicular to AC and CF is perpendicular to AB, and you have to prove that BE is equal to CF. Let's start the proof. For the proof of this, we are going to consider the triangles ABE and triangle ACF. In these two triangles, you may see that angle AEB is equal to angle AFC, as both are given 90 degree. Okay, then angle A is equal to angle A common, and AB is equal to AC, which is given to you. Therefore, by AAS, the two triangles are congruent. So I will write, therefore triangle ABE is congruent to triangle ACF, and in the bracket you may write by AAS, and it means that BE is equal to CF by CPCT. Hence proved. Exercise 7.2, question number 4. ABC is a triangle in which altitudes BE and CF, two sides AC and AB, are equal. Show that triangle ABE is congruent to triangle ACF, and second, AB is equal to AC. So we are given that BE is perpendicular to AC and CF is perpendicular to AB, since they are the altitudes. And I have already told you in the third question, altitude means perpendicular to the opposite side. And you are also given that BE is equal to CF. You have to prove triangle ABE congruent to triangle ACF. For proving these two, we'll start the proof. In triangle ABE and triangle ACF, we see that angle AEB is equal to angle AFC, because both are equal to 90 degree. Then angle BAE is equal to angle CAF. Why? Because it is a common angle in both the triangles. Then last thing is, we are given that BE is equal to CF. In the bracket I will write given. Therefore by AAS, the two triangles are congruent. So I will write, therefore triangle ABE is congruent to triangle ACF. In the bracket I will mention the criteria AAS. And the second thing which is asked, this is the first part which we have proved. Now for the second thing, since triangle ABE is congruent to triangle ACF, therefore by CPCT AB will be equal to AC. In the bracket you will mention by CPCT. Hence proved.